Hi guys, Buildzoid here, and today we're going to be taking a look at the X470 Gaming Plus from MSI. This is the first of the X470 boards that I'll be buying and testing for the channel, and so thanks to the patrons and well, basically everybody else who supports AHOC. And let's get right into this because I want to try keep this short. We'll see if I succeed. So yeah, this is the X470 Gaming Plus from MSI. I'm doing this board first because I was really hoping that it would be terrible. Unfortunately, that plan did not work out. The board is actually surprisingly decent, if not even good. So, but I think for now I'll stick with decent. Once I test it, we'll see if it can reach the good status. Anyway, before we talk about the VRM, there's a clear CMOS button down here. You don't get a power and reset though, so that's kind of like a weird choice, you know? It's just, they give you a clear CMOS, but not a power and reset. Odd. Very odd, because normally it's power and reset and no clear CMOS. Like, clear CMOS is normally on a jumper, or not even like a thing at all. You need to pull the battery. But yeah. Anyway, for troubleshooting purposes, there is no post code on this motherboard. What you do get is these four LEDs right here. They'll light up depending on which of your four core components doesn't work. So, like, if your CPU is causing an issue, there will be a CPU LED. If your memory is causing an issue, there's a memory LED. If your GPU is causing an issue, then there's a GPU LED. And when there's a hard drive issue, there's a hard drive LED. Which really it's boot media because not necessarily hard drive SSD. Whatever you're trying to boot off of, it'll light up. So yeah, that's all the troubleshooting you get on this board, which better than nothing, but not as nice as having a post code. Anyway, the last thing I want to point out is there's this completely unnecessary connector right here. Because, you know, your Ryzen CPU is totally going to pull 600 watts. Like, yeah, it's totally going to do that. It's magically going to grow an extra 24. It's going to magically grow an extra 16 cores or something like that. Because normally a Ryzen 8 core will hit like 200, maybe 250 watts on the 8-pin power connector. Um, you don't need that. Like, this is so completely pointless that I really have no idea why MSI decided to include it. My only assumption is that MSI realizes that there's people out there who go and they look at the number of power connectors on something and automatically assume that the number of power connectors something has directly correlates with how well that something is capable of overclocking. Newsflash, it doesn't. It's a power connector. It doesn't actually make your CPU, like, your CPU doesn't care about how many power connectors you have, as long as they aren't literally melting and dropping so much voltage that the voltage regulator is working with 11 volts instead of 12. That would cause an issue, but for that to happen, you'd need to be pushing a lot more than 200 or 250 watts through an 8-pin. Actually, you could probably get away with with just a 4-pin for this kind of power level. It wouldn't be ideal, but like it wouldn't immediately catch fire. You know, it might work for a bit. But yeah, so the extra 4-pin completely unnecessary, and also for the people who are wondering, because I've seen a lot of comments about this on other videos, other YouTube channels where people ask, do you need to plug this extra 4-pin in? No, it doesn't do anything. If you're like, it's not like the motherboard won't stop you from booting if you don't plug it in. So don't bother. Just plug in your 8-pin and act like this doesn't even exist. That's the best way to treat this power connector, because that's about how useful it is. If it didn't exist, it wouldn't make a difference. Anyway, let's move on to the VRM section of the video. So VCore VRM is this block right here. SoC VRM is this right here, which the SoC VRM gets a pretty funky layout. So that's your SoC, and that's your VCore. And then over here you get your memory VRM, and that's the ones I'll be covering because that's the ones that are easy to cover and probably the most important, though I'd argue this one you can kind of ignore on. Yeah, you can kind of ignore that one. that one barely, like, I don't think I've ever seen a motherboard where I've said the memory VRM is so bad that you should not buy this motherboard. I don't think that's, like, I've never seen a motherboard like that. So Yeah, that one's generally like you don't need to worry about it, especially on DDR4. Anyway, back to the important ones. Starting with the VCore VRM, since it's the most important. This may look like a 1, 2, 3, 4, 5, 6, 7, 8 phase. I can assure you that it is not, in fact, an 8 phase, because it actually runs like this. And the reason why it runs like that is because this chip up here, which is an RT8894 from Richtech, is a 4+2 phase voltage controller. And it can't do doubling. Like, you can't go and take this 4 and turn that into, run it through a 2x and get a 8. You can't do this because this thing integrates your gate drives. So you can't double off of that. Like, this thing has to be directly hooked up to some MOSFETs. So you can't actually put a doubler in between the MOSFETs and the controller to get more phases out of the controller than it normally supports. So yeah, this is a 4-phase. It's actually even more obvious if you look at the back of the board, because the outputs of these inductors are literally like, well, no, the input side of the inductors, so the side of the inductors where you have plus 12 volts, that's literally shorted between each two phases for the purposes of current monitoring. So yeah, this is a 4-phase, not an 8. Because the MOSFETs are just in parallel. But there are some benefits to doing this VRM layout. The benefits are basically just, well, you get, like, essentially what this does is that each of your 4 phases is actually much more powerful than if it only had, like, the bare minimum to make a phase is one low side MOSFET, high side MOSFET, inductor. So that would totally be a phase. But what MSI's done is they've added an extra high side MOSFET and an extra low side MOSFET, as well as one more inductor. And the end result is that you get better current handling capability as well as better thermal dissipation, because 2 low side MOSFETs are more efficient than 1, 2 high side MOSFETs are more efficient than 1, and 2 inductors are more efficient than 1, because the current going through them gets shared. So yeah, it is a more efficient design, also because it just takes up more space, it is less thermally dense, and therefore easier to cool. So this does have some thermal and power throughput capability advantages. It has no impact on your voltage regulation. Like, your output, like the quality, like the voltage ripple and the transient response of this VRM is going to be exactly the same as if this was just straight up missing. It wouldn't make a difference. It wouldn't make any difference to the output voltage ripple or the transient response of this VRM. So yeah, this is a 4-phase, not an 8. As much as it tries to look like one, it is definitely not an 8. However, it is not completely terrible, because MSI has actually used some pretty decent MOSFETs, especially on the low side. They have the On Semiconductor 4C024, and this is a 2.8 milliohm RDS-on MOSFET. Wait, that's not much of a 2 there. 2.8 milliohm RDS-on MOSFET at 10 volts gate to source. And that's actually pretty solid, because I've seen other motherboards on other platforms that need to push more power than this motherboard does, using low side MOSFETs that were like 4 milliohm RDS on. So this is actually pretty solid. This is a pretty solid choice of low side MOSFET, and with the fact that MSI has, well, a ton of them in the VRM, it actually, like, it works out pretty well. Like, this is a nice VRM design as far as I'm concerned. Well, decent VRM design. You can definitely get motherboards on X470 with better VRM efficiency, but this is not as bad as it could be. It could be a lot worse. Like, it could be 4 milliohms RDS on, and then I'd be telling you about how god-awful this motherboard is. But it's not that high RDS on, and so this looks like it should be able to handle an 8-core at full load. The high side MOSFET is a 4C029, and that thing is, well, there's no point speccing the RDS on, because the RDS on of the high side MOSFET has very little impact on the current handling capability of the VRM. So let's talk efficiency figures. So pushing, let's say like Ryzen 2000 and 1000, you're going to be looking at for the CPU at say, the highest power draw figure you're going to see is like the 8-core 2000 series, which you're going to probably look at like 1.42 volts, which is way past the like best. You're way into the the voltage curve of Ryzen. If you're running 1.42 volts, then you're very much outside of the. I mean, the optimum range is really low voltage, but this is way outside of that. Like you're really climbing up the point of the voltage scaling curve where the scaling starts to really suck, and your power consumption just keeps climbing through the roof. So generally not worth it, but if you absolutely have to run 4.3 gigahertz or something, then yeah, 1.42 volts is the way to go. And in that scenario, you're going to be looking at about 125 amps current output from the VRM, which on this VRM, thanks to the MOSFETs MSI's opted for, translates into about 18 watts of MOSFET of heat being produced by the MOSFETs. So that needs to be then cooled by this heatsink right here. And I have no idea how well that heatsink will perform because while I can read data sheets for MOSFETs, there's no data sheets for heatsinks. So I have no idea. But hopefully, I have hopes that this heatsink is capable of dealing with 18 watts of heat because, it's very heavy and it seems to have a decent amount of surface area. So I'm hoping that it can, cool the VRM enough because, it would kind of suck if it couldn't. But yeah. 18 watts of heat on the VRM, which isn't really that bad because if we compare this to, say, B350 and X370 motherboards, a lot of those boards would be hitting that, they'd be hitting that kind of heat output on the MOSFETs at 100 amps or less than that. Some boards would be doing like 20 watts plus at 100 amps output. So this really isn't that bad. Like, I'd say this is actually, this is why I'm saying this is pretty decent, assuming that VRM heatsink actually does its job. You could totally max out an 8-core 2000 series on this. Now, if you're on a 6-core 2000 series or an 8-core 1000 series and you shove 1.42 volts into those, you're probably going to be looking at a current draw around 100 amps. The 6 cores are actually going to be a tad below that. The 8 cores are going to be around 100. For that current draw, you're going to be looking at 12.5 watts of heat, which this should definitely, I have very high, I believe that this motherboard should absolutely be able to do that. Like, that heatsink should be able to dissipate that, no problem. For a VRM this size, like, that it has this much surface area, this should not be an issue. If it is an issue, then that heatsink is awful, and MSI really needs to rethink what they're doing with those. But like the VRM is not going to be running that. They should not run that hot for this current level. So that's nice. And then for 1.42 volts, 75 amps, which is say a Ryzen 1000 series 6 core, you'd be looking at about 8.5 watts, which that should actually probably work without a VRM heatsink at all. So yeah. Honestly, this V-Core VRM is not... It's not bad. I mean, as I said, it's pretty decent. And it really comes down to what the heatsink can dissipate. But I think this figure right here should be no problem whatsoever. And this, I have high hopes. I honestly believe that the board should be able to do that figure. But we'll see. It's nice to be able to test a motherboard for once. So yeah, and obviously all of these power efficiency figures for this VRM are at my typical 300 kilohertz switching frequency, 10 volt gate to source voltage. So yeah, that's the operating parameters for the VRM, though I should note that the 300 kilohertz switching frequency with this chip is not constant. it will increase the switching frequency as current output increases. But I don't know how much, or I don't know how much, or how long, or if like, I don't know how well that works because I can't get a full data sheet for this chip. But I do want to check that out with an oscilloscope. So that you might see some content about that. It might be that I just check it out for myself and then tell you about it. I don't know. We'll see what I figure out. Now then, moving on, the SoC VRM is a two-phase, and thermally this thing should have no problems because the SoC VRM has a heatsink almost as big as the VCore VRM, which is kind of like, it's kind of fun. To me, that's kind of funny, but yeah, for your CPUs, the SoC really doesn't need to push that much. You're going to be looking at like 20 to 30 amps max, and really that 20, like, honestly, that 30 amp figure would be really hard to hit. So 20 to 30 amps, and you'd be looking at about 2 to 3 watts of heat output on the SoC VRM. It again uses the high side, low side per phase setup, and the MOSFETs are the same. So that high side, that low side. 4C024 low side, 4C029 high side. And yeah, the end result, 2 watts to 3 watts of heat at these operating parameters. Now, if you go up to an APU, you might be looking at, 40 to 60 amps. I'm not entirely sure. I've not had an APU in my hands, so I've not been able to actually check what kind of power draw figures the GPU portion reaches. But this is what I've been finding on the internet a lot. It should be somewhere in between those two, depending on how heavily overclocked you are. And for 40 to 60 amps, this VRM will produce about 4.5 to 8.5 watts of heat. Wait a minute. Why didn't I update my notes? Yeah, 8.5 watts of heat. So, yeah, the heatsink, this heatsink should absolutely be able to handle that. Though I will note, I think a motherboard with more SoC phases should overclock iGPUs better. And honestly, like, this, you know what? Let's note this as a 4 big, so with a B here. So big 4. Actually, no, B4 for big 4. I honestly think you'd be better off if you took a 4-phase motherboard with like if you're going for an APU build, weaker VCore, more SoC. Like, I'd look for a 4+3 or a 4+4. I don't think there's any actual 4+4 motherboards, but I know there are 4+3s, and I'd honestly look into one of those. And I know there's also B4, like big 4+3, so those would also be a great choice for an APU. I think this is really more geared towards the CPU because I'm inclined to believe that the low phase count of the SoC VRM here would actually impact your iGPU overclocking range. So yeah, and that's a suspicion I have. I've not actually tested that. I haven't had an APU in hand yet. So, and I also don't get that many motherboards, which is why I had to buy this one. Anyway, thermally, this SoC VRM should have no issues as far as I'm concerned. Now then, moving on to the last one, the memory VRM, so the VDDR, which actually you should call that the VDDQ, but that tends to get confusing in my opinion, and I prefer calling it VDDR, so we'll just call it VDDR. So the VDDR VRM, you'd have to push like 1.5 volts at, say, 6 amps, because RAM really doesn't pull much power at all. And again, MSI has 2 high-side MOSFETs and 2 low-side MOSFETs, and they're again the 4C29 high-side and the 4C024 low-side. And the end result is that this is like super overkill. Basically, so if I just go by the power loss due, because the calculation I use for all of the VRM power draw figures is just power loss due to current draw through the MOSFETs. For this at 300 like at these operating parameters, this VRM will produce about 0.5 watts of heat, which is nothing. In fact, the bulk of the VR, like the the thing is, there's going to be heat produced by the actual drives. Like, there's going to be power loss from the actual drive circuit that's going to be significant in this figure. So this is not very, like, this is pretty inaccurate compared to some of the other ones, because like out of 18 watts the drive power is going to be really, really low, but out of 0.5 the drive power is going to be relatively very high. So yeah, but nonetheless, the memory VRM is massive overkill, and as I mentioned earlier, I can't think of a motherboard where I've said the memory VRM isn't massively overkill, because DDR4 absolutely sips power, and this is true across the entire frequency range and voltage range, and like it just like memory doesn't really get that much more power hungry as you crank up the frequency. It really doesn't. So, like I have that tested. So yeah, memory VRM is overkill as is usual for a motherboard. So yeah, that covers it. In terms of the VRMs, I'm honestly pleasantly surprised. I have high hopes for this motherboard in testing, because the heatsink, I'm not saying it's a good heatsink, because I don't bloody know. I've not run it yet. But it does, like, it inspires confidence with its volume and weight. I don't know if that actually translates into any decent thermal performance, but, you know, I hope it does. And the actual VRMs themselves aren't completely awful. Like, I'm actually really surprised about that, because, as I said, I was really hoping that, I'll buy the cheapest X470 motherboard that MSI makes. It's gonna suck, and I'm gonna have an entertaining video about how much the board sucks. But instead, I get to tell you about how it doesn't really suck that much, and that while the 8-phase, like while it isn't a real 8-phase and it's actually a 4-phase, and there's a completely unnecessary power connector on it, this is a solid motherboard. Like, I honestly think you could probably, like, it should be able to max out an 8-core. It's so solid, in fact, that I'm kind of toying with the idea of replacing the current motherboard in my daily system with one of these. With this, we'll see if I like the BIOS and there are other aspects of the motherboard, because there's obviously more to a motherboard than just the VRMs. There's the heat sinks, which you need to test. Then there's the actual BIOS, which you need to use. And then there's the actual overclocking capabilities of the board. This thing claims to be able to do DDR4 3466, which I don't really find that hard to believe. But I am interested to see where it'll max out once I get my Ryzen 2000 series CPU. Because currently I still only have a 1700, and my 1700 has like an awful memory controller that I've never gotten to work at 3600 megahertz at all. There's no, like, I've had motherboards boot 3600 megahertz. I've never had it run stable 3600 megahertz. So yeah, I'm waiting for a CPU with a better memory controller to basically test the board out. But I will be testing it with the 1700. Well, I will still try the 1700 on this board just to see how it does. And see if, the heatsink can do at least that figure right there. So yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave a comment or any questions down below. If you'd like to support what I do here with actually hardcore overclocking, then I have a PayPal, Patreon, and there's shirts you can buy. There's a link to all of that down in the description below. Huge thanks to all of the people who made the purchase of this motherboard possible. That's it for the video, so see you all next time. Where'd my mouse go? There it is.